Hello and welcome to Tech Talk. Today, we'll be covering the topic of how to automate and codify your Exadata Database Service deployments using OCI Resource Manager and Terraform. I'm Eddie Ambler.
And I'm Leo.
We'll be coming to you live today from our Tech Talk session to have this discussion. So let's look at some of our session objectives, right? Today, we'll be going over how to explore and learn how to automate and codify your Exadata Database Service deployments using OCI Resource Manager and Terraform, right? So that you can walk away understanding how to conduct discovery and how to generate baseline Terraform configurations for your Exadata Database Service deployment using the Resource Manager, right? So that you end up with a nice, easy, standard template that you can deploy over and over, removing the number one issue that we all face, which is human error out of your deployments. We'll show you how to understand how to move and manually manage infrastructure to controlled manner using the Resource Manager. You'll learn how to duplicate or rebuild an existing Exadata Database Service infrastructure deployment, including any application components that we might have in the environment, so that you can get a standard build as you move your applications from development to test to QA and ultimately into production. The other thing that we'll do is we'll show you how to use configuration source providers like GitHub and Gitlab to enable your automation as you go through your DevOps operations. Okay, so let's look at the first thing that we have on our program agenda, which is to walk through and introduce you to the cloud database services, which are for every workload, right? So we're going to introduce you to the Oracle database and to the Oracle Cloud Database offerings in this first part of the discussion. So, when architecting an application, there are usually a few questions that we as developers often ask about our application data. We'll say, what type of data does the application really need to use? Does what you need from your data change over time? Do varying stakeholder viewpoints change what you need from your data? Well, as we ponder these questions to come up with the answers, we'll get an answer that often looks like this: because the value of data and what you need from your data does change over time, and it does vary by stakeholder viewpoint. You need a flexible data store that can meet the demands of the entire database and enterprise over time. The Oracle database is a converged database solution that offers developers the ability to code in any language they like, access to data they need from one data source versus many. Oracle's multi-cloud, multi-model converged architecture supports multiple data types and data models such as spatial, graph, JSON, and XML. And also algorithms like machine learning, graph, and statistical functions. And it also supports varying workload types such as operational analytics, all within a single database. So as developers, it's key for us to make sure that we're leveraging all of the embedded database features and options that you already own at no additional costs, such as multi-tenant databases with 3 PDBs, feature functions like advanced analytics and machine learning, Oracle Graph, and spatial. So application development in the Oracle Cloud is modern and easy to use. There are over 70 public services that enable customers to build and run a wide range of applications in a scalable, secure, highly available, and high-performance environments. Oracle Cloud is open. That's a very important term. It offers choice, flexibility, portability, compatibility, interoperability with other technologies, including open source and third-party components. Oracle Cloud enables developers to build modern applications using the latest technologies, architectures, and development methodologies. For example, Oracle Cloud offers a suite of cloud database offerings, artificial intelligence, machine learning, digital assistants, blockchain, Gen 2 cloud infrastructure, containers, Kubernetes, serverless, DevOps tooling, and much, much more. So you can see the Oracle Cloud Platform goes way beyond the database. And it makes it fast and easy for developers to get started in minutes. For what otherwise would take most organizations many hours, many days, many weeks, and sometimes months just to get an environment. You know, as you can see on the screen, there are a ton of familiar developer tools and frameworks that developers can use to shorten their learning curve, right? So just because you come to the Oracle Cloud, you don't have to change your tool sets. You can still use your GitLab, your version controls, Jenkins, you know, for your automation tools, and a number of frameworks and languages that we're used to using. Oracle Cloud, you know, enables developers to build what we consider intelligent applications, right? That are powered by machine learning and advanced analytics. For example, developers can use digital assistants, which leverage conversational AI and natural language processing. Oracle Cloud also uses machine learning-driven analytics to automatically detect and predict systems management and security issues. Developers can build any kind of applications on Oracle Cloud, and that's an important point to just really stress. The Oracle Cloud isn't just for Oracle apps. It actually supports Oracle and non-Oracle workloads, also supporting all kinds of popular programming languages such as Java, Node.js, JavaScript, Python, Ruby, Go, C#, .NET, and many, many more. As a developer, you can choose from multiple cloud database offerings with varying degrees of automation and management. You just find the right cloud service offering that meets your management style and needs, such as Oracle Database, MySQL, and NoSQL. And you're not limited just to databases. You can also choose from multiple operating systems, including Linux, Oracle, Ubuntu, CentOS, Debian, SUSE, and Windows servers. So let's take a quick look at our database service portfolio in the Oracle Cloud. So as you can see, developers can choose from multiple database offerings in the cloud, right? That really, as we move from left to right, allow you to start small in a very affordable environment, using either enterprise or standard database edition, right? On VMs, you know, having workloads that are 1 or 2 cores, and growing to the far right, where the databases land on Exadata Database Cloud Service, either in our public cloud or in your cloud, a cloud at customer, right? Giving you the power and scale that you can't get on standard IaaS. And for those who need, you know, full management experience, we have our autonomous database series that actually sits on top of the Exadata platform. So not only do you get the power and scale, but you also get that full management experience as well. So as I was discussing, you know, the Oracle database is considered a converged database, right? It is actually made up of many data models and data types pre-integrated for you, so that you have less time worrying about, you know, managing multiple databases, and you can focus your time on your applications. It's the same Oracle binaries, whether we deploy it on premise, on you know, commodity hardware, as you can see on the bottom graph, or in the public cloud, or in our cloud at customer, or on IaaS in our cloud, or you take advantage of one of our other cloud offerings, such as the Database Cloud Service on VM, or the Exadata Cloud Service in public cloud, and as I mentioned, all the way out to the fully managed autonomous choice database offerings. And at the end of the day, it boils down to portability, right? Portability equals choice. By having the same Oracle binaries be able to run on-premise in the cloud, it gives you the ability to build the cloud roadmap journey that's right for you, whether that's, you know, moving as a lift and shift, hybrid cloud, or multi-cloud. Leo, if you would take us through the next part of the agenda, that would be great.
Okay, so now we go to the second topic on our agenda, which is to talk about on the challenges in terms of delivering resource deployment automation. So here are some of the key objectives that we wanted to achieve in terms of addressing common pitfalls and challenges when it comes to resource automation. So first is for the agility and repeatability. So we need to somehow have the capability of recreating or rebuilding our existing infrastructure systems into a new environment, a new region, or a new tenancy. Next is to reduce human errors, specifically on running those consistent workflows and builds, as well as to provide a standards-based build. So this is more into doing a collaboration within our group. Like we have those Terraform-based standardized templates that we can share across. And for us to provide an automated scale. So this is in connection, like as your infrastructure grows in scale and complexity. So it's very evident that it will be better for you to manage it programmatically. Then reduce complexity. So a key objective of having a Terraform auto resource discovery for our existing resources and to make leverage on the power of the Converged database. Now, for auditability and compliance, so for us to have a tool that comes with version control that can track all the commit changes that we're doing on our configuration, comes with a drift detection, as well as to comply with those mandatory processes and business directives related to compliance, and to have an end-to-end audit visibility across our infrastructure. And then to improve collaboration. So definitely to have and provide an integration across different configuration source providers. So we are talking about, it could be an existing configuration source providers in your organization. It could be another configuration source provider that could be residing on a different cloud in terms of a multi-cloud model. And for us to easily enable code pipelines, as well as to enable the multi-cloud and hybrid deployments for our resources. Now we go to the third part, which is we will show you how you can automate and codify your Exadata Database service. Okay.
So Leo, I kind of had a question there in that space. So, some of my customers have moved to the cloud, and they really are enjoying the efficiencies that they've gained. But one customer in particular, they've got 50 developers, 27 different applications with their own development life cycles. They're running DevOps, and every week, they've got different deployments going out to the field. So their DBAs are spending a ton of time, trying to create environments and keep things in an orderly fashion. Is this something that can help to reduce that churn and make them more efficient?
Well, yeah. Thank you for that question, Eddie. Well, absolutely. So in the cloud, so they can bring in the same DevOps methodology that they have, but this time in a complete DevOps cloud platform, comes with a complete CI/CD platform. So it can help them deliver the resource deployment automation. Like with DevOps cloud service, they can automate the entire software delivery lifecycle. Like they can easily develop and manage code, build, test, deliver, and deploy their software to the OCI platform. Then they can also easily do in terms of committing their changes. Like they can easily commit to their code repository. Like they can automatically trigger the start of their build pipeline to build, test software artifacts, and deliver them straight to the OCI repositories. Now, in terms of the deployment automation, so for the deployment pipeline, So on the success of their build pipeline, they can easily start the resource deployment to OCI platform. So I'm talking about the full stack resource deployment starting from their application tier, which could run on a compute service, could be a virtual machine or a bare metal, or it could be running on a container engine for Kubernetes that comes with functions, and then they can easily launch their Oracle Database Cloud Service. So did I answer your question, Eddie?
Definitely. I can't wait to learn a little bit more because I think I'm going to take some of the solution back with me.
Okay. All right. Now we go with how to achieve automation using OCI Resource Manager. So if you heard about ORM or OCI Resource Manager, so how does it work? So your OCI Resource Manager, it's a fully managed Terraform as a service. So it uses the infrastructure as a code to automate the provisioning of all your OCI infrastructure resources. So it could be your app tier, network tier, DB tier, everything. Then you can also with OCI Resource Manager, you can bring in your own Terraform template definition, and you can easily create and author a Terraform config that can be coming from your own Terraform config. It could be coming from a sample template that we have in Oracle repository. It could be your own standard templates, or you can call it private templates, or you can even import or discover an existing infrastructure. Let's say I have an existing app tier and DB tier running on my Oracle cloud, and I can easily discover that existing infrastructure for me to generate a baseline Terraform based config that I can use for me to easily provision it or rebuild the system to a different environment. Then the OCI Resource Manager, so it comes with a complete CLI, SDK, and console support. So your resource manager also integrates natively with the identity and access management or IAM, so that you can define a granular permission for your Terraform operation. So that's one of the benefits and differentiator if you have this kind of a ready tool for you to manage your entire infrastructure state. Then once you have created your stack successfully, then you can run a job to create and deploy the resources in your tenancy. So a job is defined as a Terraform action that runs on your Terraform configuration. So in OCI Resource Manager, so you can also do your Terraform plan, which is to review the infrastructure. It will generate you an execution plan. So what are the different resources that will be provisioned? And you can also run a Terraform apply, which is the actual provisioning and deployment of the resources defined in your config. So for resource managers, so what are the common problems that it solves? So or what are the common pitfalls that it addresses? So it addresses the challenge in terms of the infrastructure state management. So it helps you addresses the common pitfalls, especially on running parallel execution that leads usually to an undesirable infrastructure outcomes, as well as it helps you addresses the limited access controls around the execution of your Terraform commands, which bring us a lot of benefits. Like you can easily automate and standardize your infrastructure for you to easily replicate, clone, or rebuild as your infrastructure grows, and that it gives you the deep integration with the OCI platform, so you can utilize not just the infrastructure but even the other platform as a service services, as well as to implement identity and tagging, and of course to give you for you to seamlessly manage state files and improve your team collaboration.
So, Leo, I have another question here. So this is a pretty interesting tool. How much does this cost, right? So if I had to put a number on this to be able to gain this agility and automation, how much, how does this build?
Well, yeah, I'm waiting for that question. So to tell you, it's free. So you can just use the OCI Resource Manager. So you just need to pay on the underlying resources that you're using, like compute, database. But the tool itself, OCI Resource Manager, is free.
Wow, they'll be happy to hear that. Thanks.
You're welcome. So now we go to some of the key terminologies. So if you're new into OCI Resource Manager, so we call it a stack. So the stack represents the OCI resources that you want to create in your tenancy. So your stack can contain both Oracle and non-Oracle workloads. It could be a full stack that covers your app tier, network tier, DB tier, storage. So everything in every resources in your OCI. And then a job, as I have mentioned before, it's the one that performs the actions that are defined in your configuration. So similar to Terraform. So you have the actions such as the plan, apply, destroy, and even to import a state. Then you can easily develop shareable standards. So in OCI Resource Manager, so you can create a standardized Terraform-based configuration templates that your team can use. So you have an option for you to create your private templates. Then when it comes to resource discovery, so your OCI Resource Manager, you have a capability of creating a stack out of a existing compartment, meaning it will discover all the resources that's in that compartment, and that it will give you and generate a baseline Terraform config that ready to use for you to duplicate or rebuild your existing infrastructure. Then it comes with drift detection analysis. So drift pertains to it's comparing on the last executed configuration. Like if you did some changes, so you can run a drift detection that comes with a drift detection report that tells you what are the changes from the last executed configuration and your current stack in OCI Resource Manager. So those are the key terminologies for OCI Resource Manager. And now I will go with a demo on how I can use my OCI Resource Manager and Terraform for me to discover, automate, and codify my Exadata Database Service deployments. Okay, so in the demo, the outline is I have an existing cloud database service, which is an Exadata Database Service that I will be discovering. And from that discovered config, I will be able to generate a baseline Terraform config that I can edit and update and enhance. And I can simply create a stack out of that updated Terraform config, which means I will be rebuilding the same Exadata database service on a different compartment, which is my development environment. Okay, so to start, go to Resource Manager, click on Create Stack, and choose the existing compartment. So I will be choosing the compartment of my source or the existing Exadata database service that comes with an app tier and network tier. Then I need to choose a service. So I have an option whether I want to discover all the services that's running on the compartment, or I can specify specific services such as core and database.
So Leo, what's covered under core?
Oh, so for the core services, it covers your app tier, mid tier, which it will capture all the compute that's been running on your compartment. The network components specific to your virtual cloud network, so all the components will be discovered. Storage now and storage for the database service, it will capture all the cloud database services running on your existing compartment. So if you're running a an Oracle based database service, or if you're running an Exadata database service, so all the resources pertaining to your database service will be captured into a Terraform config file.
So essentially, this Terraform now becomes my gold standard infrastructure deployment that I can just take forward as I go through the life cycle.
Yes, so that's correct. So meaning that baseline Terraform config that you have captured from your existing compartment, you can make it as your golden image and make use of it once you deploy to other environments. So once we have discovered and captured our resources, you can simply download the Terraform configuration that you can use to update and edit and codify. So let's just take a look on the discovered Terraform config. So you can see here the the core, the database TF is here. For the core, you can edit and update, like for example in the core for the network components. So to make it work on an Exadata database service, you just make sure that you have your client subnet, backup subnet, and the other virtual cloud network components. For the database, so specific to Exadata database service, so you just need to make sure that you have the definition for the for all the resources required into Exadata database service. So starting from the Exadata infrastructure, so here you can see the OCI database cloud Exadata infrastructure. You just need to specify the model, the shape, the number of compute, then the VM cluster. So VM cluster here, you need to double check if which GI version you want to use, the display name, what will be the backup subnet to be used, the compartment ID, the cluster name, the license model. You can even specify here if you want a local backup enabled or also the sparse disk group enabled in your Terraform config. Then the number of OCPU to be enabled on your VM cluster listener port. Then from the VM cluster, you also need to define the database home resource in your Terraform. So here you can choose a specific DB version for your DB home that you're going to use on your Terraform configuration. Then database. So in the database, this is where you define the DB name, DB unique name, the workload type. Again, you just need to review because these are all being generated by OCI Resource Manager. So if you just want to standardize a field, then you can just go and edit your Terraform config. Then pluggable database. So after you've done with database, you can also define your pluggable database that will be created in your stack.
So Leo, I got another question. So in the lower environments that the customer has, they typically want more pluggable databases than others. Am I able to just edit this file here and add or subtract PDBs as part of the definition, or do I have to go through the whole process all over again?
Yep. So great question. So what I did here, because what the existing infrastructure only have one PDB. So I just copy paste the definition of the PDB to add two PDBs, because I want to create like three databases, one for my dev, UAT, and SAT. So to answer your question, yeah, it's just a matter of doing a copy paste and reusing the discovered definition of pluggable. So if you're required to create like 10 PDBs, so you can just easily do it in the Terraform config.
One last question there. What about being able to specify, in the cloud, I'm able to create custom database image, right? Which is another way I can provide standards that, guarantees an exact patch set. Am I able to reference the custom images here in my Terraform, or do I only have the choice of what was discovered?
Yeah, if you go back to the resource definition for your database, so you can reference it to the DB home specific DB home ID, and also if you go to the DB home definition, yeah, here, so you can even use a custom software image ID. So if you have created a custom software image ID, so you just need to get the OCI ID for that, and then you can make use of a custom software image for your DB home that will be used by the database being provisioned to your stack.
Wow, that's awesome. Great flexibility.
Yep. Okay, then make sure you just go through the variable set, and then yeah, create stack. Then okay, so once the stack has been created, you can run your Terraform plan just to check on the infrastructure, and then click on apply to deploy and create the resources. So here you can see that it will create first the the app middle tier. Comes with the virtual cloud network components, and then it will go straight provisioning your Exadata Database Service starting from your VM cluster, and then it will create the the three database that we have declared, which is the dev DB, the SIT DB, and then the UAT DB. Then once you see that all the resources have been applied, so you can just check in the console, like this is my infrastructure, this is my three PDBs that's been created. Okay. Then you also have an option to extend it to your GitLab or GitHub, or for the source configuration repository. So doing that, it's just let's say here I'm using my GitHub, so I just generate a personal token from the GitHub, and I just go to configuration source provider. I click on create configuration source provider, and then since this will be the GitHub source provider, so I just need to give a description like this is for my repo profile coming from GitHub. You need to choose the compartment where would like to create this, and then since we're using GitHub, so I'll be choosing the public endpoint, and I just need to provide the server URL for GitHub and then my personal access token. So after creating, I can make use of my source configuration repo as the source of the Terraform config. So after I have committed changes to my Git, then it will be pushed to my source configuration repo, which I can create a stack and choose the source code control system as my source of the Terraform config. And then as you can see, we committed to the ORM demo repo, so I can select it from the stack creation. So once I've done with that, then just click on create. So this time you'll see that your stack is being created and it's pulling the config from your configuration source information, which is your GitHub repository. So this is useful for those who wanted or who are already doing Git ops. Like you can bring in different configuration source if you're working into multi-cloud setup. So you can have a centralized source of your Terraform config. And then if you need to build something for Oracle workloads, then you can make use of the ready templates on the resource manager. Okay, so next is to talk about the different management tools. So aside from Terraform and OCI Resource Manager that I have covered. So I hand it over to Eddie.
All right, thanks for that. So yeah, Leo, thank you. That's a great job. I appreciated the demo. It was really cool seeing the automation live and how with just a few clicks, we were able to discover environments that existed and duplicate them, or even go to our repositories and have our standard builds duplicate the environments from there. So, in this model, what we're going to talk about is some of the other database service management tools that are available so that we don't have to use the console. We can actually do it programmatically. So we'll talk about the CLI, the SDKs, some of the REST APIs, Terraform, and some of those. So here on the screen, you can see that, we've been operating out of the OCI console, web-based UI, which gives us browser access via HTTPS. This is great for doing one-time or ad hoc items, but if you've got a lot of things to do, or you just you want to work programmatically, this is where the other feature functions like REST APIs come about. They allow us the ability to programmatically execute the same actions functions which we had in the console. The SDKs, there's a rich set of libraries of SDKs that allow us to build and deploy apps that integrate with the OCI services, such as the Java SDK, Python SDK, Ruby SDK, Go, and several others. We talked about the CLI, really being that extension of the console, convenient for developers and others to automate tasks through scripting. And where we've been spending a little bit of this conversation is with Terraform and Ansible, right? So Terraform really gives us that programmatic way to treat infrastructure as code, and Ansible gives us the ability to orchestrate and deploy application on top of that infrastructure. So when we put it together, we're able to deliver an end-to-end stack, right, that can be deployed to support Oracle and non-Oracle workloads, middle tier and database, small workloads or large workloads. So true flexibility in the Oracle Cloud to get just the right amount of resources you want with dependable flexibility, standards, performance, and scale. With that being said, let's look at some of the cloud automation that is there. So as you can imagine, we on the VMs that are there, we can do the creation activities, right? We can delete things, but we can do the standard operations also from on automation, right? We can start, stop, restart resources. We can scale resources, right? We can add the typical things that you would think, like such as CPU, memory, local storage. At the database layer, same thing, right? This list here is not exhaustive. It's just really there to show you that there really isn't much that we can't do from the automation tools, right? We can create our environment. We can manage the state of the environment. We can back it up. We can restore. When we need to apply patches, right, we can do that either from the console or programmatically. If we want to reorganize how things are distributed in our compartments or isolate things for security reasons, we have the flexibility to move resources, to different homes, to different compartments. And from an HA and an availability perspective, we have full control to be able to deploy not just performant environment, but environments that also are resilient and meet the MAA patterns by deploying things like DataGuard, which gives us the ability to do things like switch over and switch back. And even when we do have failures, we have the DataGuard functions to be able to reinstate our standbys once we've solved the problems. And security is key. We use defense in depth as our security methodology, and we give our customers choice, right? As you can see, you can leverage Oracle keys. Your data is always encrypted in the Oracle Cloud, but at the same time, you can have customer managed keys, right? You can bring your keys to the cloud and manage it that way as well. The patching processes that we do through the console are also available via the APIs. And to close out the feature functions discussion there from an automation is, you saw in the Terraform, there was a spot to actually put in your license model. When you're operating these environments, you could start with BYOL, right? Bring your own license, which gives you the full ability to get the most ROI out of your investment, right? I encourage you guys to, sign up for cloud and take advantage of the cloud reward support program that's there and get a discount on your support fees while you're getting the benefits of the cloud. And when you need more capacity than you have licenses for, no problem. Change the licensing model online to license included, and address the capacity that you need. So a very flexible architecture that allows you to get a more pay-for-use model so that you're always getting value. At this point, I'll turn it over to Leo, who will walk us through a few examples of how the various interfaces are working.
Okay, so thanks, Eddie. So we'll just go to a quick demo for utilizing OCI CLI and REST API. So this demo is scaling the OCPU for Exadata Database Service. So in OCLI, you have your DBVM cluster update, in which you can specify the new number of OCPU. So if you can see, coming from 16, we will be scaling up to 24 OCPUs. So aside from the console, you can make use of OCI CLI for automation. And for the REST API, so coming from a 24 OCPU, so here we have a Postman tool just for us to run the payload for the REST API. So we have those REST APIs available for the different lifecycle tasks of DB. So we're just scaling it to 16. So from 24, we're scaling it down to 16. So we're using the REST API. From 24, it's now 16 OCPU, and then we can easily run a get VM info for us to call the get REST API to show the details about our VM cluster. So that's how easy you can do it via OCI, CLI, and REST API. Then Terraform. So we have covered this a while ago. So when to use. So if you want to programmatically create infrastructure resource, then you can make use of Terraform. So I see some question in the Q&A. So so question is, where can we find the syntax for naming the OCI resources in a Terraform script? So if you go to this link, so this is the OCI provider resources documentation. So you can see the syntax here, the one that I showed in the demo, like how you will define a pluggable database resource. So you can just go to the database management and then choose the pluggable database. And then Ansible. So where to use Ansible? So if Terraform is used for infrastructure deployment, so your Ansible can be used for configuration management, or it can be your app config management for your application deployment tool. So here's an example in which you can make use of Terraform and Ansible to manage your resource deployment. So first is to use Terraform to create the app tier, which is a virtual machine, and then launch your cloud database instance. And then I can call in a Ansible playbook to install or do some necessary um, applications or installation of applications on that machine. Okay. So this here is just a quick demo of how it works. So from the discovered TF that we have, the one that we have edited, so the app tier, we can go back to that Terraform config and call an Ansible playbook. So here you can see that we are calling an Ansible playbook, which refers to a variable that's it's directed to this, the httpd install.yaml. So what are we trying to do here is, once we have provisioned our app tier, we wanted to enable httpd. So we will be asking Ansible to do that for us. So in your YAML Ansible definition, so here's the actual action that's been taken care of the Ansible, just to install the httpd after we're doing the remote exec from our compute. So same thing, we just upload it again, the zip file, and then we create a stack, and then we do the apply. So once the apply has been successful, so we have now an app tier which have the httpd enabled. So if you check on the console, so when you log into the machine, so you can just check that the Apache HTTP server is already up and running. So that's how easy you can use Terraform together with Ansible. So Eddie, I'm also thinking of a use case like for database. They can also make Ansible to set some required parameters into the DB, right, sir?
Oh, I absolutely right. So, Ansible is an orchestration engine. So any software that you need to lay down, any standards that you need to enforce, right? Any data that you might need to load after your infrastructure has been deployed, your Ansible can orchestrate that and ensure that by the time you get to the end of the process and you hand your environment to the end user, that it meets your standards, not just from infrastructure, but from a software perspective as well.
Okay. For Ansible, so we have a Ansible OCI collection. So these are the collection of playbooks that you can use to start with your Ansible project. Okay. So
Leo, that was pretty awesome. What would be great is if you could grab those two registry links, the one for Terraform and Ansible,
yeah,
in the chat. I'll just go ahead at this point and ask, are there any additional questions? We kind of covered a number of questions as we were kind of going along. Any additional questions at this point?
let me just oops, sorry. Let me just paste the link.
All right. Yep, I see it here in the chat. So that's
So that's for Terraform. Just need to grab the Ansible. Okay.
So Leo, do me a favor, grab those and put them in the Q&A window.
Okay. Hold on. Yeah, I think we can also see the chat. I put it there.
Awesome. All right.
Yep. Then other resources. So we have our Slack workspace. So we have a public Slack workspace. So there you can get access to our get started guide. So we keep on posting get started guides for cloud database services. We also have those how-to demos and GIFs. And we're also posting replays for our Tech Talk series and also those upcoming Tech Talk that we'll be doing for the month. And then where can I find other collaterals? So you can also check www.oracle.com/database and www.oracle.com/Exadata. So for the Slack channel, so yeah, we invite everyone to join the discussion. So it's everything about cloud database services. Okay, so here's the join link. I'll be also sharing this in the chat. So how to join? So just click on the join link. It will ask you to log in your email account for Slack. Then you need to check your email, configure your 2FA, and that's it. So welcome to our workspace. So, yep.
Well, with that, we're drawing to a close on this particular topic. I really hope some of you find value. Thank you. I'm Eddie.
And I'm Leo.
Till we meet next time.